So in this sum, we have to integrate sin x plus cos x upon 9 plus 16 sin 2x within the limits of integration 0 to pi by 4 with respect to the variable x. Now this sum is a special type of sum where we have a special type of substitution, and that is primarily again based on the fact that whatever is the numerator, you should think of such a function whose derivative is the numerator here. So, but in this case it's not directly visible here, but it is somewhere embedded or hidden inside the denominator. Just look at it. How? Now if we ask ourselves a question, we have sin x plus cos x in the numerator. What is the function whose derivative is sin x plus cos x? Cos x is the derivative of sin x, and this plus sin x is the derivative of minus cos x. So exactly speaking, sin x minus cos x is the function whose derivative is cos x plus sin x, which is precisely the numerator written with us, right? So this helps us, or this gives us an idea what to take as our substitution. So I have taken sin x minus cos x as t. Differentiating, we get numerator along with dx as dt. So it has been modified. I've written dt here. Now 9 as it is, 16 as it is. Now about sin 2x. This portion is very, very important, and this step again is very, very important. Here, whatever we have substituted, we have to take its square. It becomes sin square x plus cos square x minus 2 sin x cos x. So it is sin square x plus cos square x, which is 1, and minus as it is for 2 sin x cos x, we write sin 2x. On the other side, it is t squared. From here, we can get the expression for sin 2x if I shift it to the other side and shifting t squared to the left hand side. Sin 2x comes out as 1 minus t squared. The same sin 2x will be replaced by 1 minus t squared. So what I get is 1 upon 9 plus 16, 1 minus of t squared, which can again be simplified and be written 9 plus 16, that makes it 25, minus 16 of t squared here. Now once I have taken the substitution, I have to modify the limits. That's an obvious step and very, very important. So if I take t as minus 1, if I take original limits over here, if I take t as 0, so what we get is coming to the substitution, we have x is equal to 0 here, sine of 0 is 0 and cos of 0 is 1, so t takes the value minus 1, so I've written minus 1 as the lower limit of integration. Now if I take x as pi by 4, feed it here, sine pi by 4 and cos pi by 4, they are equal. So each one of them being pi by 4, 1 upon root 2. So they'll cancel out. So the upper limit after modification in terms of the new variable t will be 0. So now this is a very, very simple sum left with us. It's just like the formula 1 upon a square minus of x square. So I'll prefer converting the coefficient of t square to unity simply by picking or dragging the 16 outside the integral and thereby dividing the adjoining term by 16. Modifying it, writing 25 by 16 as pi by 4 whole square. 16 I've already taken outside. This is t square. Now this is like 1 upon a square minus of x square, which is 1 upon 2a log mod a plus x upon a minus x. In place of a we have 5 by 4, in place of x we have t. So it is 1 upon 2, in place of a we have 5 by 4 log mod a plus x, that means 5 by 4 plus of t, upon a minus of x means 5 by 4 minus of t within the limits minus 1 and 0. On application of limits, if I put t is equal to 0 over here and here, the upper limit, so we get log 5 by 4 upon 5 by 4, which reduces to log 1, which is in fact 0. And from there, I have to subtract the value of same expression for t is equal to minus 1. So when I put t is equal to minus 1, go for LCM on simplification, we get 5 minus 4 upon 4, which comes out as 1 upon 4 in the numerator, and minus 1 here gives us 5 plus 4 upon 4, that makes it 9 by 4 here. 4 and 4 will be cancelled out from both the denominators of numerator and denominator. I'm left with log of 1 upon 9 over here. Log of 1 upon 9 can also be written as log 1 minus log 9. Log of 1 is always equal to 0 here. So what we get here is 0 minus this 9 can be written as 3 square. So I can write 2 log 3 using the formula n log m, or if you wish you can write your answer as minus 1. This log 1 is 0, so you can write minus minus plus log 9 and product is 1 upon 40. Your answer can be 1 upon 40 log 9, or if I further simplify it, we have log of 1 as 0. 9 can be written as 3 square, for which it can also be written as 2 log 3. I've written it here. Opening this bracket, we get minus minus plus. This 2 divided by 40 makes set 1 by 20 over here, and log 3. So your final answer in this case comes out as 1 upon 20 log 3. This is again very, very important sum. Over to the last question, question number 10 of this sequence.